Jai children, in our last video we studied about electronic configuration. What is electronic configuration? Arrangement of electrons in an atom is called electronic configuration, or otherwise distribution of electrons in the subatomic level or otherwise subshell are called electronic configuration. So we studied how can we write the electronic configuration of elements having atomic number up to 80. So for example, if you want to write the electronic configuration of sodium, in the class 10 you studied it possesses atomic number, it having atomic number 11. The atomic number of sodium is 11. So what it will do? So how can be these 11 electrons are distributed? So you studied in class 10 281 is the electronic configuration of sodium. What is the meaning of 281? In the first shell it having 2 electrons. Otherwise, the K shell, that is the first shell, having 2 electrons. And the second shell L having 8 electrons. And the third cell having only 1 electron. So, K shell. So, last class we studied this shell having subshell. So, K shell having only 1 subshell, that is called S. So this S can accommodate 2 electrons, so K shell can accommodate the 2 electrons. You studied in class that K shell can accommodate 2 electrons. Where the 2 electrons are present? It is present in the S orbital or otherwise S subshell. So, similarly the L, next energy level L shell having 2 subshell, one is S and another one is P. To differentiate this and this S, what we are doing? This we are represented as 2S and 2P. These 2 indicate the second energy level or otherwise second shell. So, similarly this can be expressed as 1s. So, this s orbital can accommodate 2 electrons, p orbital can accommodate 6 electrons, 6 plus 2 equal to 8. You studied in class 10, L orbital can accommodate 8 electrons. How the 8 electrons are distributed? In S it is having 2 electrons and 2p orbital is having 6 electrons. Similarly, M shell, the third shell having S, P and D subshell. This can be differentiated by 3S, 3P, 3D. S can accommodate 2 electrons, P can accommodate 6 electrons and D can accommodate 10 electrons. Totally 10 plus 6, 16 plus 2, 18 electrons. You studied in class 10, M shell can accommodate 18 electrons. How these electrons are distributed? This is the way it is distributed. Similarly, N shell can accommodate 4s2, 4p6, 4d10, 4f14, totally 32 electrons. 14 plus 10, 24, 24 plus 6, 30, 30 plus 2, 32. So, M shell can accommodate 32 electrons. Similarly, if you go to the next level, K, L, M, N, O subshell. O shell. O shell can accommodate 5s2, 5p6, 5d10, 5f14 and 5g. Next orbital is coming 5g. 5g can accommodate 18 electrons. Total if you count, you get 50 electrons can be accommodated in O subshell. It will go like this. So now we are writing electronic configuration of sodium. How sodium? First energy level having s orbital 2 electron. Second energy level 2s and 2p. S orbital can accommodate 2, p orbital can accommodate 6. 6 plus 2 8, 8 plus 2 10. Now remaining one more electron. Where it will goes? It will goes to the next 3s level 1. This we studied in our last class. Now write the electronic configuration of potassium. Last we studied up to argon. Now we are going to write the electronic configuration of potassium. How the electronic configuration of potassium? So for writing electronic configuration, first we have to write potassium. Symbol is K. Atomic number is 19. So for writing electronic configuration, as per subshell level, we have to write 1s2. Then we have to write 2s2. 2p6. Then we have to count just how many electrons? 2 plus 2, 4. 4 plus 6, 10 electrons over. 19 electrons are present. So we have to write the next level. The next electron goes to 3s2. After 3s2, the next electron goes to 3p. P orbital can accommodate 6 electrons. Now you have to just count how many electrons are present. 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. 12 plus 6, 18. One more electron we want. But we know that the third energy level having 3d orbital. So the next electron goes to, automatically the next electron goes to, where it will goes? It will goes to 3d orbital. 3d 1. But it is wrong. The third, the last electron goes to 4s1, not 3d1. Why? This is the problem. So as per we studied in our last video, so for writing electronic configuration, the electrons are entering as per subshell level. We studied first energy level having only one subshell, second energy level having two S and P subshell, third having 3 subshell SPD, 3P completed. One more electrons remaining, automatically it wants to go to 3d level. But the correct electronic configuration of potassium is 4s1. Actually this is explained by a principle called APA principle. Electrons are entering inside the subshell only based on energy state. It says in ground state, electrons are entering inside the subshell only based on energies. That means the first electron goes to subshell or otherwise orbit which having very low energy. So 1s orbital possesses very less energy, whereas 2s orbital having some more energy than that of 1s orbital. 2s orbital having somewhat less energy than 2p orbital. 2p orbital is having less energy than 3s orbital. It will go like this. So APA principle says electrons are entering inside the subshell only based on energy. So for that, for describing this, it will explain the energies of subshell through a diagram. The diagram is 1s orbital. We know first shell having only s orbital. Second shell having s orbital and second shell having p orbital also. Third cell having s orbital, third cell having p orbital and third cell having d orbital also. Fourth cell having s orbital, fourth cell having p orbital, fourth cell having d orbital and fourth cell having f orbital also. Fifth cell having s orbital, fifth cell having p orbital, fifth cell having d orbital, fifth cell having f orbital. And even fifth cell having G also. Fifth cell having G also. So how the electrons are entering? First it will enter 1s orbital. After completing 1s, it will goes to 2s orbital. After completing 2s, it will goes to 2p orbital. After completing 2p, it will goes to 3s orbital. Then 3s orbital to 3p orbital. After completing 3s orbital, it will goes to 4s orbital. After completing 4s, it will goes to 3d orbital. 3d to 4p, 4p to 5s. Again it will goes to 4d, 4d to 5p, 5p to here 6s will come. Like that it goes. This is called Abba principle. The Abba principle says that in ground state, electrons are entering inside the subshell only based on energy. For describing this, we can understand that by using this diagram. From this diagram, you can understand first 1s orbital will fill, second 2s orbital will fill, then 3s will fill, then 3p will fill, then 4s will fill, then 4s, after 4s again 3d will fill, then 4p will fill, 5s will fill. Like that it goes. So always remember this in your mind. So now for writing the electronic configuration of potassium, how can you write the electronic configuration of potassium? For writing the electronic configuration of potassium, atomic number 90. So 1s2. So after filling 1s2, which will come 2s2 to p6. So after completing 2p6, automatically 3s2 will come, then 3p6 will come. After completing 3p, 3d is present, but electron will goes to 4s1. Since there is no electron in 3d, we can leave 3d. So the correct electronic configuration of potassium is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. So once again, I will give another one example. How can you write the electronic configuration of calcium? For writing calcium, you know atomic number 20. So how can you write 1s2, 2s2, 2p6, 3s2, 3p6. After 3p6, 6 plus 2, 8, 8 plus 6, 14, 14 plus 2, 16, 16 plus 2, 18. How many electrons are remaining? Only 2 electrons. Where the 2 electrons can go? After 3p, 4s2. This is the electronic configuration of calcium. This is electronic configuration of calcium. Like that, we can write the electronic configuration of any element based on this. I think you can understand all these things. Now you have to practice by writing the electronic configuration of any element. But always keep in your mind, which you have to keep in your mind, Abba principle.